Welcome to the Podkey Summary of Power and Performance Group Lab from WWDC 2026. A lot of this week's developer news comes down to one theme: making performance work less guessy and a lot more visible. There are better tools for comparing instrument runs, clearer ways to read launch time, new MetricKit upgrades for Swift, and a bunch of practical advice for SwiftUI, background tasks, and even heat and battery limits in the real world. It's a kind of update that doesn't sound flashy at first, but if you've ever spent hours trying to figure out why an app feels a little off, this is the stuff that saves your week. One of the nicest quality of life upgrades is a new diffing feature in instruments. Developers can now record multiple runs, name them, and compare the call trees side by side in one place, instead of doing that awkward two-window comparison dance. The important part is that regressions and improvements show up immediately, so you can see which functions actually changed between runs and decide faster whether a tweak helped or hurt. That shortens the whole tune, test, squint, repeat cycle quite a bit. MetricKit also got a Swift first redesign, and this feels like the version a lot of people wanted from the start. It works with Swift concurrency, so developers get async and await access to daily reports and more fine-grained metric intervals in a way that fits modern Swift code. There are also new diagnostic and metric types that are only in the Swift API, which is a pretty clear nudge to move off the older Objective-C style interfaces that are being deprecated. In plain English, the metrics pipeline is getting more useful and less awkward to wire up. Apple also said some of its own internal launch optimization work is now shipping as a built-in benefit for all apps. So the time from tap to first frame can improve without developers changing any code, which is a rare and lovely sentence in software. That launch interval is measured through MetricKit and Xcode Organizer, using low-overhead system hooks that capture the exact stretch between the user tapping the app and the first screen draw. That matters because launch performance usually gets argued about in fuzzy terms, and this makes it much less fuzzy. There was also a useful reminder that thread hopping during launch adds real overhead. If work keeps bouncing across threads, the context switch histogram in instruments will show it as a spike, and that switching cost can drag out startup. If you're staying under a few hundred context switches per launch, it's probably not worth panicking over. But if the count is much higher, consolidating work onto fewer threads can tighten launch latency in a measurable way. On the SwiftUI side, over-invalidation got some deserved attention. That's when views keep redrawing, even though nothing visible has really changed. And it creates this quiet little storm of CPU work, while the screen looks perfectly still. The result can be higher foreground energy use and battery drain. That's hard to explain if you're only looking at what the UI appears to be doing. Using the observable macro, along with the SwiftUI instrument, can help isolate those unnecessary redraws and cut that energy churn down pretty dramatically. A related SwiftUI issue is environment property churn. Putting lots of values into the environment is usually cheap enough, right up until those values start changing constantly. When that happens, downstream views keep reevaluating, and that can turn into visible hitches or just a lot of wasted work. The SwiftUI instrument can surface that churn, which gives developers a chance to limit high-frequency updates or move mutable data out of the environment. And if an app is dealing with really large data sets, like 50,000 records or more, the guidance is pretty straightforward. Batch it. Break the data into pages and lean on lazy VStack or lazy HStack, so only the on-screen rows get materialized, instead of asking the device to enthusiastically build the whole universe at once. MetricKit's new state reporting sounds simple, but it could end up being one of the most practical additions. Developers can tag samples with custom app states like loading, idle, or background, and then slice the metrics by those states to find the real hotspots. So, instead of knowing the app uses too much energy in general, you can see that maybe the loading state is the problem, while idle is perfectly fine. That also pairs nicely with metric goals, because teams can compare the energy use of a specific state against a baseline expectation rather than treating the whole app as one blur of activity. For large SwiftUI datasets, that same approach can categorize batch sizes as small, medium, or large, and compare how each affects launch and scrolling without logging every single item count. For background tasks, the advice is to chunk long-running work into small, resumable pieces. That way, if the system needs to pause your task because something higher priority shows up, the app can resume later without losing all its progress. That's a lot healthier than treating background work like a stubborn marathon that refuses to stop for water. Instruments now also shows thread priority and preemption data, which helps teams spot cases where their QoS settings are causing throttling or scheduling friction they didn't realize they were creating. There was also some very practical guidance for apps that push hardware harder, especially AR and metal apps. When the device moves into a higher thermal state, apps should listen for process.info.thermal state notifications and gracefully back off. That can mean requesting lower resolution assets, reducing frame rate, simplifying shaders, trimming network payloads, or easing up on animation complexity. Some of that relief comes from the system, like lower display refresh, and some has to come from the app itself if you want the experience to stay usable in real-world heat, including direct sunlight. And for teams trying to understand how an app behaves on older hardware without maintaining a museum drawer full of phones, low power mode is a handy proxy. Turning it on lower CPU frequency on a modern device, which can expose the same kinds of bottlenecks older devices would reveal. Pair that with network throttling or thermal simulation tools, and you can test against a much more realistic range of conditions. One last piece here is metric goals benchmarking against peers. The exclude organizer can aggregate anonymized field data across apps and show how a team's launch or power metrics compare with similar apps in the same category. That's useful, because performance work can easily become a bottomless pit if you don't know what good enough actually looks like. If you're already in line with your peers, maybe you stop chasing tiny gains and spend that time elsewhere. If you're behind, now you know it's not just a hunch. Taken together, these updates feel very grounded in the daily reality of shipping apps. Fewer blind spots, better comparisons, and more ways to connect performance numbers to what users actually feel. And honestly, anything that helps catch a battery drain bug before your users do is worth a little appreciation. This episode was generated by Podkey. Create your own at podkey.fm.